Alright, so welcome back. So the video for today is on permutation and combination. Now, what is permutation? Permutation is simply the arrangement of objects in a specific order. So in permutation, the order actually matters. Now let's say we have the letters A, B, and C. So in how many ways can we arrange this ABC? So we can arrange this ABC as number 1 ABC. We can arrange it as what? ACB. We can arrange it as what? BCA. We can arrange it as BAC. We can arrange it as what? CAB. We can arrange it as CBA. Now, look at how many ways. 1, 2, 3, 4, 5, 6. So we have 6 ways of arranging them. Yes. So you can see how permutation works. You're arranging them in a specific order. So ABC is different from what? CBA. Even though this one is the reverse of this, they are still different under permutation. Let's look at another example. Now, let's say we have the letters A, B, C, D. In how many ways can we arrange it? So let's do that. We have A, B, C, D. We're going to have A, B, D, C. We're going to have A, C, B, D. We're going to have A, D, B, C. We're also going to have A, D, C, B. So this is one way. Now let's start with B. We have B, A, C, D. We have B, A, D, C. We have B, C, A, D. We have B, C, D, A. And we'll keep going on and on and on. And we finally get all this. So if you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have a total of 24 ways of arranging A, B, C, D. But there should be an easier way of calculating this. That's when we have factorial. If you have n objects, the number of way of arranging it is n factorial. Yeah, it's exclamation mark, but we call it n factorial. So we do n minus 1, n minus 2, n minus 3. So that means the value of n is decreasing by 1 in each time. So let's say we have, for this now, we are going to have A, B, C, D. So that's 4 letters. So your n is equals to 4. So the number of ways of calculating is going to be, so for this, your n is going to be equals to 4. So n factorial is n minus 1, n minus 2, all the way to 1. So now your 4 minus 1, so you do 4, then your 4 minus 1 is 3. Your 4 minus 2, you get 2. 4 minus 3, you get 1. So you are just reducing it by 1. 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is 24. So that's 24 ways of arranging 4 objects. Now for this ABC, 1, 2, 3. So that's 3. So that's 3 factorial, which is 3 times 2 times 1. That's what? 6 ways. Yes, 5 factorial is 5 times 4 times 3 times 2 times 1. 120. 6 factorial, you get 720. Yes, a special thing to take note of is that 0 factorial gives you 1. Yes, 0 factorial gives you 1. That's going to be equal to n factorial over n minus r factorial. So your n is going to be equal to the total items, while your r equals to the items taken at a time. So n equals to the total items, r equals to the items taken at a time. So let's say you have that you should calculate the number of ways you can arrange 3 books out of 5 books. So the number of ways of arranging 3 books out of 5 books. So 3 books will be the items taken at a time, while 5 books will be the number of, that's the total item. So we're going to have 5 permutation 3. That's going to be what? N factorial, which is what? 5 factorial over n minus r. This is your n, this is your r. So that's going to be 5 minus 3 all factorial. So we have 5 factorial, which is 5 times 4 times 3 times, we can stop at 2, but once you stop at 2 that you have not reached 1, you have to add factorial with it. Then all divided by 5 minus 3 is 2, so that's going to be 2 factorial. So you can cancel this 2, cancel this 2. 5 times 4 times 3, 5 times 4 is 20, 20 times 3 is 60. So there are what? 60 ways of arranging 3 books out of 5 books. Yes. So anytime you have a factorial, let's say 6 factorial, once you have not gotten to the 1 and you want to stop, let's say 6 times 5 times 4, and you want to stop in 4, make sure you add your factorial so I will know that there's still something you are still going to do after this 4. So let's try these examples so you can pause and solve, but let's try them. So we have 7 permutation 4. So the formula is going to be what? Equals to n factorial, which is what? 7 factorial over n minus r. N minus r are going to be 7 minus 4 factorial. So now let's simplify 7 factorial. So 7 times 5 times, now we know when we do 7 minus 4 we are going to get 3 factorial. So let's stop at 3 factorial here. 7 times 5 times 4 times 3 factorial. Then all divided by what's 3 factorial. So we can easily cancel this out. Yes. So, sorry, this is going to be 7 times 6 times 5. Yes. 7 times 6 times 5 times 4. So, 7 times 6 times 5 times 4 is going to give you 840. So we can say your answer is what? 840 ways. Yes. So your answer is 840. So let's try this other one. 10 permutation 3. So that's going to be n factorial, which is 10 factorial over 10 minus 3 factorial. So 10 minus 3 is giving us 7 factorial. So let's stop at 7 factorial here. So that's going to be 10 times 9 times 8 times 7 factorial, all divided by 7 factorial. Cancel this out. 10 times 9 is 90. 9 times 8, 90 times 8 is going to give you 720. So you can see how easily this is done. Now we have permutations with repetition. So consider this word excellence. So now we want to, how many letters does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know the number of ways of arranging it is what? 10 factorial. But now if we look at it, we can see that there are some letters that are repeated twice or 3 times. So we have the letter E. 1, 2, 3, 4. So the letter E is repeated 4 times. So what are we going to do? We are going to divide by the factorial of the number of times it was repeated. So that's going to be 4 factorial. That's for letter E. Look at letter C. It was repeated twice. So that's going to be 2 factorial. And letter L also was repeated twice. So divided by another 2 factorial. So now we can simplify this 10 factorial as 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, because we have a 4 factorial down here. So 4 factorial, 2 factorial is 2 times 1, and the second 2 factorial is 2 times 1. So we can cancel this 4 factorial out. 2 can go here 1, 2 can go here 3, 2 can go here 1, 2 can go here 4. So we now have 10 times 9 times 4 times 7 times 3 times 5. So we can point this in our calculator and we are going to get 37,800 ways. So we have 37,800 ways of arranging this word excellence without repetition. So 37,800 ways. So if you have the word Abuja, so how many times can we arrange this? So first 1, 2, 3, 4, 5. So that is 5 factorial. Now you can see that the word A is repeated So we have 2a's. So you're going to divide it by 2 factorial. So we can have 5 times 4 3 times 2 factorial, all divided by 2 factorial. So we can cancel out 2 factorial. 5 times 4 is 20. 20 times 3 is 60. So we have 60 ways of arranging the word Abuja. So now we have conditional permutation. So this has to do with permutation when a particular condition is made. So in how many ways can letter of book be arranged if figure 1 the O's are together? So now they say we should pretend as if the O's, we should consider when the O's are together. So we have the word B-O-O-K. So that means these O's are going to be together, so they are treated as one letter. So if we treat it as one letter, how many letters do we have in total? We have 1, 2, 3. So that's going to be equals to what? 3 factorial. So which is 3 times 2 times 1. So we can see that there are what? 6 ways of arranging if the O's are together. Now if the O's are apart, now let me show you one method you can use. So if the O's are apart, now let's first calculate the number of ways of arranging the word book itself. So the word book 1, 2, 3, 4 can be arranged as 4 factorial, then divided by, since we have 2 O's, 2 factorial. So that's going to be 4 times 3 times 2 factorial, all divided by 2 factorial, which is going to give us 12 ways. So if you want to calculate the number of ways of arranging when the O's are apart, you can now do number of ways of calculating when the O's are apart is this minus this. So you are going to have 12 minus 6, and you are going to get 6 ways. So 6 ways is now the total way of arranging when the O's are apart. Yes, you calculate the total way of arranging the word itself, then the total way of arranging it when they are together. So when you subtract them, you calculate the total way of arranging when they are not together. Another way to do this is, okay, since we said the O's are apart, so let's write our B and our K. So we can actually place the O's here, here, or here. So that's 3 ways. Yes, 3 ways. That's 3 gaps. So we can say 3. Then how many O's do we have? We have 2 O's. So that's 2 factorial. So 3 times 2 factorial is what? 6. So that's another way of calculating. Now we have 5 people are to be arranged in a row. Now when you see the word arrange, just know that it's permutation you're dealing with. Yes, arrange is the keyword for permutation. In a row for a group photograph, how many arrangements are there if a married couple in the group insist on sitting next to each other? So we have a total of 5 people. Let's call them A, B, C, D, and E. So now let's say the married couple is A and B, and they insist on sitting together. Okay, so now we are going to have 4 total ways. We treat them as one. So 1, 2, 3, 4. So we are going to have what? 4 factorial ways of them being arranged. Now don't forget there are 2 couples, so always multiply by that 2. So we're going to have 4 factorial times 2. 4 factorial is 24, and 24 times 2 you get 48. So now we have circular objects. So if something is arranged around a circular object, how do we calculate? So the formula for calculating permutation based on circular objects is n minus 1 factorial. So if 5 people are seated around a circular table, so the number of ways of arranging is going to be what? 5 minus 1 factorial, which is going to be what? 4 factorial. And we know that 4 factorial is what? 24. So that's a simple way of doing round circular objects. Now if that circular object can be flipped and still look the same, like a ring. Now if you flip a ring, you will not know if you have already flipped it. It's still going to look like the same ring. But if you flip a table, you know the legs are going to be up, then the surface is going to be down. So it does not work for table. So it works for like ring. Now if you flip a ring, it will still look like that same ring. So the formula for that one is going to be n minus 1 factorial over 2. So let's say we have 7 beads. So we want to arrange 7 beads around a ring. So how can we do that? So we're going to do what? 7 minus 1 factorial all divided by 2. So 7 minus 1 is 6 factorial all divided by 2. We know 6 factorial is 720, and 720 divided by 2 is 360. So there are 360 ways of arranging 7 beads of different color around a ring. So now we have combination. So combination is similar to permutation, but in combination the order does not matter. Yes, the order does not matter. So let's say we have something like C A B and we have B A C. In combination we'll say that they are the same thing, so we can take them as one. But in permutation, because of the order, we will say that they are two different things. But combination, the order does not matter. Yes. So now let's say we have the word ABC. So we know under permutation we can arrange it as ABC, ACB. We have BAC, BCA, then we have CAB, then we have CBA. But under what combination, we can say that ABC is the same thing as what CBA. So these two are similar. This is similar to this, and this is similar to this. So we can just say there are 1, 2, and 3 ways. Yes, 1, 2, and 3 ways of arranging the words A, B, C, because we are not looking at the order. Yes, so the order does not matter. So we just A, B, C, C, A, B, and then we have C, B, A. No, we have B, C, A. So you can see that in this one we just have 3 ways of arranging. So this is under combination, and the key word for combination is actually selection. Yes, most of the time you see selected. So the key word of combination is selection. So now let's look at the general formula for combination. So this is the general formula for combination. N combination R equals to n factorial over n minus r factorial times r factorial. So this one is different from permutation, and it has another extra r factorial at the bottom. So let's say we have 5 combination 3, that's going to be 5 factorial over 5 minus 3, which is 2 factorial, then your r factorial, which is 3, so that's 3 factorial. So you can do 5 times 4 times and stop at 3 factorial. Yeah, because 3 is the highest factorial at the bottom. So times 2 factorial, 3 factorial. We can cancel this out. 2 factorial is 2 times 1, which is still 2. 2 in 4 gets 2. So our answer is 5 times 2, which is what? 10, which is 10. So our answer is 10. So 5 combination 3 gives us 10. Now we have this one. Find the number of ways of selecting 8 subjects from 12 subjects in an exam for an examination. So we see the keyword selecting. It can be also choosing. Yes, if you see the word choose or selecting, it is combination. So the number of ways of selecting 8 subjects from 12 subjects. So the total subject is 12. So that's going to be 12 combination 8, which is going to be n factorial. This is your n. 12 factorial over 12 minus 8 factorial times your r factorial, which is your 8 factorial. So your 12 can be written as 12 times 11 times 10 times 9 times 8 factorial, all divided by 12 minus 8 is 4, all divided by 4 factorial. Yes, then times your 8 factorial. So 8 can cancel 8. Then 4 factorial is what? 4 times 3 times 2. So we can write it as 12 times 11 times 10 times 9 over 4 times 3 times 2. 4 times 3 is 12, so this 4 times 3 will cancel this 12. Then this your 2 can go in 10, which is 5. So we have 5 times 9, 45, then 45 times 11. So we are going to get your answer as 495. Yes, 495 ways. So this question says we should find the number of ways a committee can be formed consisting of 2 men and 1 woman from 4 men and 3 women. So this is actually a combination question. It's a find number of ways something can be formed. It does not have to do with arrangement. So a committee consisting of 2 men, yes, and we have 4 men. So we're going to have 4 combination 2. Then you multiply it with the women so the women, we have 1 woman and we have 3 total women. So we're going to have 3 combination 1. So now we have n over n minus r, that's 4 minus 2, which is 2 factorial times 2 factorial. Same thing for this. So 4 factorial is what? 24. 2 times 2 factorial, that's 4. So 24 divided by 4, that's 6. Then 3 factorial is 6. 6 divided by 2 is 3. So we are going to have 6 times 3. That's going to be what? 18 ways. So this question says, in how many ways can a delegation of 3 be chosen from 5 men and 3 women if at least 1 man and 1 woman must be included? So total men, let's call it TM, equals to what? 5, and the total women equals to 3. So now a delegation of what? 3. Okay, so now what do we do? So let's look at the way of selecting 1 man. And they said the delegation must be 3. So now we can have either 1 man and 2 women in the delegation, or we can have 2 women and 1 man in the delegation. So now if we have 1 man in the delegation, we're going to have 5C1, then times, if we have 2 women, the total women is 3, so that's going to be 3C2. So we're going to add it to the other way they can be selected. So let's say we add 2 men, we're going to have 5C2, then times, let's say we add 1 woman, we have 3C1. So you can see the total delegation is 2 plus 1, which is 3. This also is 2 plus 1, which is 3. Then you go on and simplify. So I want to give you a task, yes, an assignment or a classwork. Try to simplify this. You're actually going to get 45. So there are 45 ways of what? There are 45 ways of choosing 5 men and 3 men from a delegation of 3, if at least 1 man and 1 woman must be included. So we have 45 ways of performing this operation.